So in 8.1, we are learning 3 of the 4 methods to solve a quadratic equation. So if we have something like ax squared plus bx plus c equals 0, the first thing we've decided is that if this is factorable, we're going to factor. To factor, you're using the zero factor property. Okay, so you're setting it equal to 0, factoring, and then setting each factor equal to 0 and solving. The second method we learned was what I call algebraically. The textbook calls it the square root method. Now, this is only doable when you have something like x minus 5 all squared minus 3 equals 0, because what you can do is solve algebraically. You can isolate the x, or something just simply as 2x squared equals 5, right? So any of these ones where you can isolate x, that you can use the square root method, also called algebraically. If it's in this standard form and it's factorable, you're going to do that. But we need to learn what to do when they are not factorable. So for example, if I give you a question like 2x squared minus 8x minus 4, you're looking for two numbers that multiply to give you positive 8 and add to give you negative 8, which is never going to happen. And maybe some of you are screaming at the screen, but you could grade as common factor first, and I sure could, right? But this is still not factorable. So regardless, what you're going to notice is that you've got a trinomial that's not factorable, and because it has the x squared and the x term, I can't solve algebraically for x. I can't get x by itself yet. But what I can do is I can solve this one by completing the square. I can make this perfect square so that I can solve algebraically for x. So I can turn it into the square root method. So we've already practiced this. You guys already know how to solve by completing the square. It doesn't change. Step number 1, you're going to complete the square as in 8.6. So step number 1, you're going to grade as common factor off the leading coefficient off the 2x term. So I'm going to take the 2 off of the x squared and the x term. So I'm left with 2 times x squared minus 4x. Then I'm going to make a perfect square. To do that, I'm going to add and subtract half the middle term squared. So half of negative 4 is negative 2. Negative 2 squared is 4. So I'm going to add 4 and subtract 4. But I don't want the negative 4. That's not part of my perfect square. So to take it out, you're going to multiply it by the 2 in front. So I'm left with 2 times x squared minus 4x plus 4 plus 2 times that negative 4, taking it out of the bracket, plus the 4. That leaves me with 2 times, now I'm going to complete the square with this guy, so it's x minus 2 all squared, and then I'm going to collect like terms. I've got negative 8 plus 4 is negative 4. So now, step 2, solve using the square root property. So really all we're doing is a first step to make it look like one that we can solve using the second method. And to do that, you're just going to isolate x. So you're going to divide by 2, then you're going to take the square root of both sides. When you take the square root, there's 2 answers, plus minus. Then you get x minus 2 is equal to plus minus root 2, and then you just add 2 and you're done. So let's try a few. So if you're reading the textbook, or if you watch other videos on this, you'll notice that some of the videos, instead of just like leaving that minus 2 on the end, they'll actually add 2 and put it on the other side. This is great, and you can do this because these are equations. When we were finding the vertex, however, right, ax squared plus bx plus c, when we were finding the vertex by completing the square, you'd have to move it over and then move it back, so we never did it. So if it makes more sense to you to get it out of the way now, you can, or you can do it the way that we were doing it before. So I'm going to just do it the way that we've been looking at it, just to keep things the same, but I will show you sort of the difference in what the textbook does for these. So step number 1, factor the leading coefficient off of the x squared and the x term. Done, it's a 1. Then I'm going to add and subtract half the middle term squared. So half of negative 6 is negative 3, squared is 9. That's my perfect square. I'm going to add it, I'm also going to subtract it, and leave that minus 2 on the end. This is the part that's my perfect square, so it's going to factor to x minus 3 all squared, half that middle term, minus 11. Now, if I was to graph, I could tell that my a value is a 1, it's a normal parabola opening up, my vertex is at 3, negative 11. But if I want to find the x-intercepts, I'm going to add 11, and I'm going to get x minus 3 all squared is equal to 11. Then I'm going to take the square root of both sides. Make sure you put a plus minus. You get x minus 3 is equal to, that looks like a 5, but it's a 3. There we go. Is equal to plus or minus the square root of 11. And then I'm going to add 3 to finish. So I have two x-intercepts, one at 3 plus root 11 and one at 3 minus root 11. If they don't say what to solve, like whether it's exact solutions or approximate, always leave it as simplified exact. You're never going to go wrong with that. Okay, so if you felt good about that, the only thing I wanted to mention is that, again, if you were the textbook, they go like this. They move that 2 over. And not only that, instead of adding and subtracting 9, they actually add 9 to both sides. So if you look at the way the textbook does it, I believe this is what the textbook does, is that it gets you right to this point. So if that makes sense to you, and it's not too much of a stretch that it makes it different than 8.6, please feel free to do this. But if it feels too wrong, or you're not too sure, like, why am I adding 9 to both sides? Just add 9 and subtract 9, right? Then you've added 0. The reason they can do that, as long as what you do to one side you also do to the other, you haven't changed your equation, that's why they do that. So you kind of find your own way with this. If you're watching videos online about this topic because you're a little bit confused, just know that they might do it a little bit differently. I made the conscious decision that I wanted to be consistent, which is why I tend to show it like this, so that even when we go back to finding the vertex, it doesn't feel like we're doing something new. So again, looking at this guy, you're going to factor the leading coefficient off the x terms. There isn't one. So then I'm going to write it out. I'm going to take half the middle term squared. So half of 10 is 5, squared is 25. I'm going to add it and subtract it. Now this part is my perfect square, factors to x plus 5 all squared, then I've got minus 20. Now that I've changed it to a perfect square instead of an x squared plus an x term, I can solve algebraically. So I'm going to add 20 to both sides. So I'm left with just x plus 5 all squared on the left is equal to 20. I added 20. Then to solve, I'm going to take the square root of both sides. So I'm left with x plus 5 is equal to plus or minus the square root of 20. If you want to put that into this step, you can. Okay, and then, hopefully that 20 is screaming at you, I'm just going to keep finishing solving for x. I get x is equal to negative 5 plus or minus the square root of 20. And this is great. This is an exact solution, but it's not simplified. So make sure you always look to see if your radicals will simplify. So the highest perfect square factor of 20 is 4. The square root of 4 is 2. And I'm left with negative 5 plus or minus 2 times the square root of 5. All right, this last couple examples, I'm going to put in a coefficient. So here we go. These make these a little bit more complicated, but not impossible. So looking at this equation, again, being consistent. If you're finding the vertex, you have to do it from here. Because this is an equation, you could divide everything by 3. So you notice how this 9 divides by 3 as well. But it's hard to know when you're allowed to do that and when you're not. So if you're finding the vertex, you can't get rid of things because finding the vertex, it's an expression, not an equation so much, right? Because it's equal to y, it's not equal to 0. So if you're doing that, that minus 9 and the whole 3 factor matters. So you can't divide by 3 right off the bat. Because this one is an equation, if you wanted to, you could divide everything by 3 at this point, but I'm just going to be really consistent. So I feel like instead of knowing when you can do what, if you just do the same thing all the time and you know it's safe, you're good. And then when you're ready, you'll start being like, hey, you know what? Because this is an equation and I could divide every term by 3, I could do that and make this term simpler, but only because I'm finding the x-intercepts and not the vertex. So again, I'm just going to be safe. I'm going to factor the leading coefficient off your x squared and your x term to be left with 3 times x squared plus 2x bracket minus 9 equals 0. Then you're going to take half your middle term squared, which is 1, and you're going to add it and you're subtracting it. Now, I don't want the negative 1 in there because it doesn't help make my perfect square, so I'm going to multiply it by the 3. So I'm going to be left with 3 times x squared plus 2x plus 1 plus 3 times that negative 1 minus 9 And you're left with 3 times, this is the perfect square of x plus 1 all squared, minus 3 minus 9 is minus 12 equals 0. Now I've turned it into an equation that I can solve algebraically using the square root method. So I'm going to add 12 to each side. I get 3 times x plus 1 all squared is equal to 12. Then I'm going to divide each side by 3. I'm left with x plus 1 all squared is equal to 4. Then I'm going to do this using the square root method. So I'm going to take the square root of both sides, plus minus. You get x plus 1 is equal to plus or minus the square root of 4, which hopefully everybody recognizes is 2. And then you're going to subtract 1. So x equals negative 1 plus or minus 2, which is negative 1 plus 2. And x equals negative 1 minus 2. So my two answers are negative 3 and 1. Whew, this is turning into kind of a big video. So this is great. But what I want to point out to you here is that when you're solving this one, when you get these nice exact solutions, it means that your original question was actually factorable. So you know how we solved this using the square root method? I just want to show you that if this was a question that just said solve, if I had greatest common factor that 3 out of everything, I would have seen that this trinomial is factorable. Two numbers that multiply, oops, sorry, that was a minus 3. I was like, why isn't this working? Minus 3. Two numbers that multiply to give me negative 3 and add to give me positive 2 are positive 3 and negative 1. So see how solving by completing the square worked? Okay, not too bad. But if I had noticed that this was solvable by factoring, I could have done it in 2 steps. So just keeping an eye on things, that when it tells you how it has to be solved, you have to do it that way. But if it just says solve for the x-intercepts, you get to choose your method. Factoring, square root method, and completing the square. All right, pause the video, give this one a go. Hint, first step is to factor that 2 off of your 2 front terms. So hopefully you did give this one a go. Let's see how you did. So I'm going to greatest common factor out that 2 to be left with x squared plus 4x. Leave my space, minus 9 equals 0. I'm going to make this into a perfect square by adding half the term, middle term squared. So 4 divided by 2 is 2. 2 squared is 4. I'm going to add it and subtract it. Now again, the only part of this that I need is the plus 4, so I want to take that minus 4 out of the bracket. To do that, I'm left with 2 times x squared plus 4x plus 4. And then I've got the plus 2 times the negative 4 minus 9. Then I'm going to factor this guy. It's x plus 2 all squared. Minus 4 minus 9 is minus 13 equals 0. And again, everybody's steps might look a little bit different for this, especially if you watch any videos or if you read the textbook. I'm doing it this way for consistency. Okay, but don't forget, if you wanted to add that 9 and just get rid of it on the other side, you totally could do that. You know, there's all these different things that you can do, but we're all going to get to here. So then we're going to solve for x. I've got 2 times x plus 2 all squared. I'm going to add 13 to each side. Then I'm going to divide by 2. Maybe people are going, oh no. And the reason you should be going, oh no, is because all of a sudden we have a radical in the denominator, which is, oh, how did I get 13 there? Sorry about that. Hopefully you're all, hey, I'm going to catch this one early. 8 minus 9 is not 13. Sorry about that, guys. Hopefully this is the one that you did by yourself and you're just rewatching and you were like, Karen, you're making a mistake. Negative 8 minus 9 is negative 17. There we go. I'm going to add 17. Sorry about that. So hopefully you guys aren't confused. So again, we factored the 2 off of my 2x terms to be left with x squared plus 4x. We've got the minus 9 on the end. We created our perfect square by taking half the middle term squared and adding it, subtracting it, taking the subtracting 1 out of the bracket by timesing it by the 2. And then we can create this perfect square bracket. Collecting like terms, negative 8 minus 9 is negative 17, not negative 13. And then we're just solving algebraically. So I'm at this point here. I'm going to get x plus 2 is equal to, now, plus or minus the square root of 17 over the square root of 2, because we took the square root of both sides, plus minus. What's wrong with this? Well, the 17 is simplified, but I don't like an irrational denominator. So I'm going to rationalize it now. I've got x plus 2 is equal to plus or minus root 34 all over 2. Now, to finish this off, we are going to get x is equal to, I'm going to subtract 2 from each side to get negative 2 plus or minus the square root of 34 divided by 2. This is a great answer. This is wonderful, it's beautiful, but it won't necessarily always be the answer that's in the back of the textbook. In fact, it won't be. And the reason why it's not is that the next lesson, we're going to learn a shortcut to this. We're going to be learning the quadratic formula, if you remember this from any math you've taken. And look at the form it's in. It's only one fraction. And so this is just another method of solving. In fact, this is the quadratic, or solving by completing a square, done algebraically. But because you get this nice one fraction answer here, they want you to have a nice one fraction answer here, which is unfortunate, but it's the truth. So what they do is just make a common denominator of 2. So I'm going to multiply this fraction by 2 over 2, and I end up with negative 4 plus or minus the square root of 34 all over 2. And that's my final answer. So yeah, it's kind of unfortunate. I feel like this is the method that should win, because completing the square is like the grandfather of the quadratic formula. But because the quadratic formula exists, they like the answer in this form. Okay, they're both correct. If you answered this on a test, I'm not going to take marks off on you, but if it's multiple choice, you should be able to recognize this. Plus the back of the book will give this answer every single time. All right, good luck.